The hottest ticket in high tech today? The AI factory. But what exactly is that? And how can companies make the most of their expensive AI infrastructure? Suffice to say, it pays to think through what kind of AI your company needs and which kinds of workloads will be involved. Learn more and save yourself millions of dollars by checking out this episode of Future Proof.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Cavanaugh here, and I'm so excited to have my buddy Mark Madsen on the line, Third Nature, back from a couple trips. Ran into him in San Diego at the TDWI conference where we met 20 years ago. Time flies when you're having fun. And we also have Denise Muyco with us of Ravel, and we're going to unravel how all these amazing AI technologies get built these days, what they actually do, and what all the workload management is about in the background. Because as you can imagine, there's a lot of processing done. There's a lot of work that's done to get into those GPUs, to adjust the weights and balances and all these parameters. And that's how it actually gets done. So we're going to talk about AI factories. That's the super cool thing that NVIDIA is talking about. And lots of other companies are talking about their AI factories. It's like, ooh, what's that? Is there an actual factory and the machines? I'm like, well, yeah, it's called a data center. And they're ingesting data, but we're talking massive amounts of data. So if you have some model with billions of parameters, I did a show, gosh, maybe 8 or 9 months ago with the folks from Hammerspace, and they were talking about how, with their tier zero storage and their whole interesting approach here, they've been able to cut the hops data takes from 10 down to 4 to get from where it's stored into the GPU. Well, that's a lot of hops. And what David Flynn, their CEO, talks about is that really a lot of the energy consumption occurs in the CPU units on the storage nodes. So they're also pushing something else very interesting right now called the Open Flash platform, where they're trying to get the manufacturers to basically realize, hey, we can connect NVMe direct to all of these GPUs, and you can basically expedite the whole process and also lower the cost and lower the consumption of energy and all this fun stuff. So this is some of my background, but the person who really knows about that is Denise Muyco. So Denise, welcome to DM Radio. Tell us a bit about yourself and
Eric.
tell us what you think about this AI factory thing that they're talking about.
Yeah, well, thank you, Eric, for having me. It's great to meet you too, Mark. Just a little quick background about me. I'm kind of what I guess you would call what they now call a hard engineer. So I have a mechanical engineering background in thermodynamics, and got into, I would say that on the business side, in a very kind of interesting, circuitous way, but got into media entertainment and doing HPC processing for films, for visual effects, advertising, gaming. So I got into that. So I know I've been in and around HPC for a very long time, for almost 20 years, dealing with very, very complex workflows and very, very heavy workloads. So we kind of got pulled into, with Ravel, we got pulled into the AI world about 5 years ago. And what we do today is we call it helping to modernize and optimize both data centers and HPC and AI environments. Means a lot of different things, but we help do that through our orchestration and automation software that we call Ravel Orchestrate and Orchestrate AI. So that's just kind of where we come from. But to answer your question about what is an AI factory? It means a lot of different things to a lot of different people. So you'll see, like with the OEMs that you see, like your Dells and your Supermicros and your HPs, what they call an AI factory is basically infrastructure that is optimized. Think of it like a cluster of infrastructure, primarily with some GPUs and some, side saddle CPUs, in either a rack or in some sort of kind of container like a chassis. And it's basically getting ready to be deployed, with some kind of software sitting on top of it.
Hmm.
And that software is generally going to be your AI engines, and your models. So that is what I think a certain group calls an AI factory. Other people call an AI factory. Um, that's actually a data center, as you just had mentioned. So a data center that has a bunch of these high performance compute specific for AI. And that's one of the big challenges that are happening right now, which is taking some existing data centers and converting them into AI factories. So
Hmm.
that is the definition of what I know.
Okay, no, that's a good definition. And I do want to get into the weeds a little bit here to kind of explain to people why this all matters. And I think when you and I were talking earlier, I mentioned how I had a whole past life in the pre-press industry and then some friends who did video effects way back in the 1990s. So, it's like a long, like 3,000 years ago in ancient history. And when you render these really complex visuals, it takes a long time.
Yeah,
And back in the day, you would scale up, right? You would have a big fat machine with lots of RAM and processors and all
yeah,
this stuff. And then, of course, we got to scale out. That was the whole cloud world with Hadoop. And they talked all about commodity hardware, which
yeah,
at the time I thought to myself, there's something sketchy about what you're telling me. And I think when you get down to brass tacks, you really have to get the configuration right and understand
yes,
these machines. And
yeah,
in fact, my data scientist who worked on it with me, a guy named Dr. Jeffrey Malofsky, what he found was, yeah, guess what? The better machines work better. Period. They just
yeah,
work better.
yeah,
And you just run into all kind of problems because that's the real problem with this high performance computing
yeah,
is you throw these massive workloads, you really better know what you're doing because they
yeah,
will just choke the daylights out of your system. The choke could
yeah,
happen anywhere. It could happen in the
yeah,
network, it could happen on the processor and the application and all kind of
yeah.
stuff, right? And that's where you guys come into play in helping to democratize and take an agnostic approach to the environment, right? You want to talk about that?
Yes, yes. I think to your point, it's really about understanding what is the workload. And to understand the workload is what is the size of the origin files that you're looking to process. And then you get into, well, what are the both the AI engines and the AI models that you are using, because that will tell you. Obviously, something that is inferencing like an LLM is very different than generative AI. And you're talking about multiple, you can say like all, the fun words you like to say is like the multiple vectors and all that fun stuff. It's very, very complex. And when you're talking about generative AI, it's just more. And then you have to, of course, then deal with other parameters within that, within just the processing. And that is, again, matching what is the right size for that workload based on that data. What is the in a data center, and if you have different types of configurations, it's basically matching up the best the best configuration for what that workload is, right? And so then you can go into the next layer, which is, okay, well, if I want to optimize my machine, the machines that I have available to me, well, what does that look like in terms of the workload? And then I want to get to the next level as well. Okay, so I've got these machines, and I'm looking at things like power utilization, right? That's another factor. And so you can chase electrons, you can chase time, you can chase dollars, right? And those are all of the factors. Those are some of the major factors that we are helping solve with what existing data centers have today with their power consumption, right?
Right.
So those are some challenges right now. Is power is a huge issue for existing data centers that want to put in a bunch of GPUs, right? So they have to work
Hmm.
with the utilities, right? And those are real practical kind of issues that all data centers, neo clouds, et cetera, are facing today, which is how can we solve the issue, with power.
Right. Well, and I'll throw one more over at you, and then we'll get Mark's opinion on this. We also talked the other day about virtualization and VMware. And I'm old enough to remember when VMware came along and it was like, hey, wait a minute, we can help you optimize the use of your machinery because, CPU usage would be very low and before we had VMware and they would sort of spread that workload out. And I think they were the first to really understand that and try to help you optimize
Yeah.
that environment. And then, of course, years later, Kubernetes comes along and I had a conversation with Alex Gallego from Red Panda a couple months ago, and he made a joke about artificial general intelligence. He said, "Yeah, well, if AGI ever does come around, maybe it can figure out how Kubernetes works." Which I thought was pretty darn funny. But anyway,
Yeah.
just real quick, I'll throw that over to you because you're optimizing for the environment. And what's cool is
Yeah.
that, as I recall, with your policy engine, you let
Yes.
people determine, hey, do I
Yes.
want to optimize for cost or for
Yes.
speed or for energy use or whatever,
Yes.
which is declarative in nature, right?
Yeah. Yes. So there's basically two modes. You can do that in a manual way or an automated way. And so when we say the word automated, if you have multiple data centers, which that seems to be a big issue right now as these larger data centers are turning over their older infrastructure and they're doing a refresh. Um, the challenge is that they have so much power right now in a single data center, and if they have a footprint of, we'll call it, 1 million square feet, I'm just throwing out a number, basically a fourth of that is now only can be utilized with GPUs. If they were to have a GPU infrastructure and now taking the place of that refresh, they're only utilizing from a square footage perspective only a fourth of that, of the
Hmm.
fourth of what's going on. So that is a big challenge, which then leads us to, you know, okay, so you need more horsepower, so to speak, with respect to, you need more GPUs to do the workloads. And so that is kind of where the value is. We've been called the automatic transmission, in many kind of use cases when you're dealing with these workloads. You have multiple different kinds of workloads in a queuing system, and that queuing system does leverage, as you just explained, our energy, the actual policy that is based on the two or three things, or it could be the 10 things that matters most to you, and basically just distribute those workloads to the appropriate environment, if you will.
Hmm, that's very cool. I'd love to get deep into the weeds here. Mark
Yeah.
Madsen, I'll bring you in from Third Nature. I love this policy approach that they take, saying let's optimize for cost or optimize for power, for efficiency, or whatever it is. That's cool stuff. But you've got history in the HPC world going back a couple decades, right? So, and I was always kind of confounded that I never saw a whole lot of innovation go from the HPC world over to the enterprise data world. I remember I was at a conference in Austin in like, I don't know, 2015 maybe, and there were none of the players from the big data world that I knew. There's no Cloudera, there was no Hortonworks, there was no MapR, like none of those guys are around. And I think it's because the universities are their own ecosystem, and this is life sciences, and so it's real heavy duty, millions of facets. It's not, like transactional data for a business. It's a very different storyline. But what are your thoughts about HPC back then versus what you're seeing in the world today?
Yeah. When you talk about vendors like that, vendors have to choose where they're going to make their money.
Hmm.
And in the commercial world, uh, there's a lot more tolerance for slop. There's a lot more, the workloads are more, I guess I'd call them mostly forgiving. I mean, certain things have to be important. I mean, the reason all those vendors you just listed are extinct is because they didn't meet the availability and performance requirements that were required for data work. And
Hmm.
we're kind of, back to some different players and IBM and Oracle and, the usual suspects again, unfortunately. Um, and it was being driven by workload. Those engines were only good for about 10 to 15% of what an enterprise needed to do.
Hmm.
And you can take that same rule and go back to the period you were talking about and why HPC tech seemed not to make it into our markets, enterprise markets. And I think that was what did we use HPC for? Well, number one, we got mired down in message passing infrastructure as a style of programming, which is really esoteric and not like hacking some Python code or Java code or whatever. It's not something you just toss out to your average guy and just say, "Hey, go vibe code this." It's also the kinds of things that you ran there were simulations mainly. So you were doing physics simulations, nuclear test simulations when we stopped doing nuclear tests and started just simulating them, weather simulations, different types of things. A lot of them were agent-based, so you just had these, cell-based. So you just have like a 3D pixel for your, weather model, and you just have billions of these things, and you do some calculations on each little cubic inch of or cubic centimeter of air, right? And so the calculations are very small amounts of data, very high compute. That does not look anything like an enterprise.
Hmm.
And so that world always stayed a little bit separate. And then personally, I view it as getting hidebound too, because you progress through statistics and machine learning and things start to intersect where you build models and large volumes of data. And then it gets more towards, hey, look, we've got deep learning. What can you do with it? Well, let's build, word2vec and BERT models and language things. And then along comes, transformers on the one side, of course, different ways of using deep learning on different kinds of models that are not language models, like protein folding or, well, AlphaGo would be its own special hell, but these different types of workloads. And so now you've got things that can be commercially applied.
Hmm.
And at that point, I think it starts to really force this intersection, which leads us back to Denise's work, right? Because we don't have any infrastructure for this in
Hmm.
enterprises, excepting the handful of companies that are either, in the AI space or, for me, more interesting, pharmaceuticals, genomics research, power and energy management, very large data set, data and compute models, which is, I break workloads based on data and compute as my first cut 2 by 2. High
Hmm.
compute, low compute, high data, low data. Where do you fit in this? I can very quickly say this is the kind of infrastructure you'll need. I'd kind of
That's
like to,
interesting.
I jabbered on about the history there, so kind of getting us to where we are, but I'd like Denise's take on that too, because, that's a thing. It's different.
Yeah. Workload orchestration, and what kind of workload do you have? And the business world is not like the HPC world. HPC means high performance computing, for those who don't know. It's out of the universities, and again, it's for really challenging, very, very complex problems like weather predictions, for example. Lots of data, lots of little nuggets go into doing all that. But Denise, I'll throw it over to you just to comment on that, and what you think about how we've kind of had this forced intersection now, in part because of the large language models.
Yeah. Um, Mark's absolutely right, with the way that, the structure of it's the structure of the data meets, well, what's the compute requirement, right? So those two are the two main kind of intersections of, well, what is that's the description of a workload. Where have gotten really involved in HPC, when I say back in the day, it sounds, like back in, like, as you say, in the early 2000s, or in the, in the 1900s. It was all, I was in the media and entertainment business, and really kind of focusing on HPC for visual effects, when visual effects was getting very hot. So you have your Lucas and your Lucasfilm and ILMs and your Pixars, and they were the ones that were always pressing the envelope. And I always like to say that's kind of where I really, cut my teeth there when it comes to HPC, primarily because they're doing always the most fascinating things in terms of like really pushing the parameters and of how to like manage compute. And you should see all sorts of interesting contortions of with blades, like with compute blades with no chassis. It was fascinating, with an ice block, and with the fan blowing. It was fascinating in terms of like, that's kind of the way that people would cool the chips at the time, because there was not enough enough to, we were overclocking all of those machines, right? To kind of get the HPC result of a visual effect. So I've been doing that for a very, very long time in terms of the I would say the last 20, 30, 20, 25 years, but it's really where things started to take shape, where more, I would say, commercial application was about 5 years ago. And I'm sure, people called it, machine learning. I mean, I would say the visual effects industry has been doing this for a very, very long time.
Hmm.
And even doing a little bit of inferencing. That we didn't call it that though. So, because the rise of these models, because of ChatGPT, this whole like world has really kind of accelerated its need to understand. And I think the understanding is coming. I would say there's only a few people that really understand, AI and what it, not just how to create a model, but how to train one and how to use it. There's lots of like subsequent like businesses that are spinning out because of it. But where we are finding most of our use cases, when we talk about enterprises using this, it's primarily in the LLM world. And that's, things like if people are wanting to use chatbots for some industry specific things. So if it's like something like with medical or medical records, that's slightly different than understanding the consumption of, a visual medical record, for example. But that's a good use case. So the medical industry, Mark was talking about what's going on with possibly like genomics. That's a whole nother level that's happening. But they've been doing that for a very long time. Like that's been going for a long time. It's just more, faster, you know, and seemingly better. But when we get into other types of use cases, for businesses, it's things like, very simple things like doing a search or looking up, for like the legal world and what they're doing, as it relates to either not just finding documents, but kind of creating documents, pulling things together, making that happen very, very quickly. There's so many different applications of AI, and most of the businesses today, most Fortune 1000 companies are absolutely have made a commitment, a financial commitment. And part of the challenge that we're seeing right now is that a lot of people bought the AI infrastructure, and there's this gap that is, really prevalent, which is like, okay, we bought all this fancy infrastructure, we're ready to go, let's figure out what to do. And it stops, right? It stops because it's well, what are all the things I have to have in order to put a model on that infrastructure? What does that look like? And so it's that ability to provision all those like little small DevOps things that are required, with the scripting and the Python this and that, right? It's very, very, I would say, detail oriented and, I would say cantankerous for for lots of it, right? It's complex. It's like unwinding like a necklace that's all balled up. So the whole point, and one of the things that we try to do is make it easy, the easy button for all of that kind of in between GUWare, between something that is bare metal, like just infrastructure, through to the actual application itself, meaning the AI engine, and being able to just direct yourself to, well, where's the origin files coming from? Okay, where do you want the output files to go to? So something very, very simple that helps people negotiate the path that's required to get into AI. That is kind of where there's lots of challenges right now, and where we see
Hmm.
ourselves, helping, enterprises, data centers. That's where we see where we are most valuable.
Yeah, that's very interesting stuff. And I'm reminded of one of the things to bring in David Flanagan from Hammerspace. One of the things that he told me last year, we were talking about training models and how long it takes. And he joked, he said, look, the GPUs we have today, you could absorb all the text in the world in one day
Yeah.
into these GPUs. But videos are a much different story. And that's when you're talking about origin files, right? That's
Yes.
what you mean, is that you have these
Yes.
big honking files where the file essence is
Yeah.
so large and there are so many bits and bytes in that file essence. So how do you absorb that? reminds me of my grandfather's joke, and I'll throw this to you, Denise, and then Mark, and you can comment on it. He always jokes, "How do you eat an elephant? One bite at a time," right?
Yeah,
It's like, but you
exactly.
parallelize. I mean, that's really
Yeah,
what you're trying to do is you're trying to parallelize. And what Ravel does is it helps you sort of dynamically orchestrate for the environment that you have. So depending
yes,
upon how much memory you have, how fast the processors are, how many cores they have, what version it is, of
yeah,
different pieces of hardware,
yeah,
all that really matters if you're
yeah.
trying to make it all hum, right, Denise?
Exactly, exactly. I think one of the big things that people forget about is that VRAM. So I've been on so many calls, with enterprises and with other data centers, and they are buying, millions and millions of dollars of GPUs and CPUs. But the one thing that they have that they forget is they're like, oh yeah, we'll get you, we'll get this X amount of VRAM, but they don't answer the question, which is, well, what is the workload? What are you trying to do? Right? Because you were talking about earlier about NVMe and what Hammerspace is doing to kind of basically take some of that that process data and move it quickly into storage, right?
Hmm.
That is the right answer, I think, in many ways. That is a right answer, I should say. But that is always kind of the challenge, that when you're in these enterprises, what I end up doing is doing a lot of like consulting by asking the questions. Well, again, what is the workload you're trying to do? If you want to do multiple types of workloads, you want to do everything from something that's generative AI, which is intensive, and it requires a lot of RAM, VRAM in there, and requires, absolutely NVMe would be fantastic, but not everyone can use that or afford that. So then you start to kind of cut corners, and what is the experience, and you want to overclock things. Do you want to do that? Are you using, liquid cooling? If you're using liquid cooling, maybe you can overclock it. There's all of these kind of very interesting facets that come into making a decision, again, based on what current infrastructure you have, and then inevitably people want to buy new infrastructure. And so what does that look like, right?
Right.
And so everyone's trying to save power. I go back to power because that seems to be one of the biggest, you know, uh, I would say mandates, at least here, in not just in the United States, but also in all of the European countries, everywhere, which is, how do you conserve power in the world of AI when there's so much more consumption going on with power? And where everyone's turning to is really on the cooling side.
Hmm.
And so how do you cool the chips? How do you preserve power for those GPUs and CPUs? How do you do that? And that is kind of where everyone's looking more towards direct to chip cooling, evaporative cooling, immersion cooling, which is my favorite because it's
Right. They're
it's like
underwater.
these it's
Right.
like literally in this coolant and these chassis, things that you never would think, oh my gosh, I can't imagine
Right.
this type of electronics into this liquid. It's like it's fascinating, right? And so they're saving power by doing this, immersion liquid cooling,
Hmm.
and trying to save that power. So now you can deploy those, those really heavy workloads or those persistent workloads to something that is immersion cooled, and now you're kind of helping get that the requirements, saving the requirements, if you will, for something else, whatever the something else is. Maybe it's another
Hmm.
another rack.